Your MCP server has pre-built message templates ready to use, but how do you actually fetch and render them in your application? You'll see the simplest way to retrieve a complete prompt sequence with just its name, then process the generated messages. We'll work with the raw GetPromptResult object and examine how each message's role and content gets structured for immediate use.
Async with client. Hash simple prompt without arguments. Result equals await client. Get prompt, welcome message. Hash result, MCP types, get prompt result. Hash access the generated messages. For message, in result messages. Printf role, message role. Printf content, message content.
This demonstrates the template method pattern applied to AI conversation flows. Prompts act as reusable message templates that encapsulate both content and structure, allowing dynamic generation of conversation sequences from predefined patterns. The distinctive aspect is the separation between template definition on the server and template instantiation via client requests, enabling consistent messaging with runtime customization. The pattern works through declarative composition, where prompts define message roles, content structure, and argument placeholders, while the client provides concrete values at execution time. This creates a clean contract. Servers expose capabilities as type templates, and clients consume them through a standardized interface without needing to understand the underlying implementation. The automatic serialization of complex arguments to JSON strings maintains type safety while ensuring compatibility with the MCP protocol's string-based requirements. This approach solves the problem of maintaining consistent, reusable conversation patterns across different AI interactions. It reduces boilerplate by centralizing message templates on the server, enables rapid iteration through argument-driven customization, and ensures compatibility across different client implementations. The trade-off is some initial setup for prompt definitions, but this pays off significantly when managing complex conversation flows or multi-turn interactions at scale. Let's break it down line by line.
Async with client.
Async context manager pattern ensures proper connection handling with automatic cleanup when the block exits, preventing resource leaks in async operations.
Hash simple prompt without arguments. Result equals await client. Get prompt, welcome message.
This fetches a pre-registered prompt named welcome message from the MCP server. The await handles the async operation, returning a structured result containing generated messages. This is the standard pattern for retrieving reusable prompts without runtime arguments.
Hash result, MCP types, get prompt result. Hash access the generated messages. For message, in result messages.
The result messages collection contains the AI-generated response structured as message objects. This pattern mirrors how LLM APIs return multi-turn conversations, where each message has a defined role and content. Iterating through messages handles cases where the prompt generates multiple responses or conversation turns.
Printf role, message role.
This prints the message role, identifying whether the content is from the system, user, or assistant. Role metadata is critical for maintaining conversation context and determining how the AI should process each message.
Printf content, message content.
This outputs the actual generated content from the prompt. In AI systems, this is the critical payload, the model's response that would be shown to users or processed by downstream systems. Prompt rendering pattern. The GetPrompt method transforms static templates into dynamic conversations by merging arguments with message structures, creating reusable interaction patterns. Arguments passed to prompts must be JSON serializable, as FastMCP automatically handles type conversion for complex objects. This approach separates content generation from business logic, enabling consistent AI interactions across your application.
The prompt that speaks every language understands none.